Hello everyone, I'm Adam. In this problem, for the curve given by our polar equation, which we have as r equal to 2 times 1 minus sine of theta, we're going to be finding our derivative, dy dx, and then the slopes of the tangent lines given at these points on our curve over here. So let's start by finding our derivative. So the polar form of our derivative, say dy dx, we know is given by this long fraction, which we have as f of theta times cosine theta plus f prime of theta times sine of theta divided by negative f of theta times sine of theta plus f prime of theta times cosine of theta. Okay, where f of theta is our r, right? That's just a function of theta that we have that's giving us our curve. So let's go ahead and mark this out. So, right, r is our f of theta, and so that's 2 times 1 minus sine of theta. We'll go ahead and distribute that too. So our f of theta is going to be 2 minus 2 sine of theta. And so looking at that, we need f prime of theta. So taking the derivative of this, we're just going to get f prime of theta is negative 2, say, cosine of theta. Okay, so now using this, we're going to plug it into our equation and find what our dy dx is. So dy dx is equal to, we'll give ourselves some space here. Okay, so f of theta, where that's our 2 minus 2 times sine of theta times cosine of theta, plus f prime, or plus negative 2 cosine. So we just have minus 2 cosine theta times sine of theta. And then on the denominator, minus f of theta, so minus our quantity 2 minus 2 sine theta times sine theta, again, plus f prime, or plus negative 2 cosine, so minus 2 cosine theta and times cosine theta. Okay, so let's take a look at what we have here. Now, there's a couple different ways that we can proceed. We can obviously simplify this a little bit. If we look at least in the numerator, I can factor out some 2's and I could factor out a cosine and maybe combine some terms, but actually I'm going to leave it as is. And it might look more complicated to do this, but for what we're going to see in a second, this is actually in a pretty usable form. Now, whether to leave it like this or whether to simplify kind of comes from experience. Now, why I'm going to leave it like this, we'll see when we find our first point. So this is our dy dx. I'm sorry, the slope at our first point. This is our dy dx. Now what we want to do is find the slopes at the given points on our curve over here. So we'll start, say, with our point 2, 0, and we'll just work our way maybe clockwise. So at our point 2, 0, which again, these are points in polar form. So this is giving us r and theta. So our dy dx, right, which will give us the slope, plugging everything in, well, starting off, you take a look at this first term, 2 minus 2 sine theta. Well, that's just equal to r. So according to this point, that whole value is just 2, which of course you can get if you plug in the value of theta. You get sine of theta is 0, which leaves you with just 2. Which should happen because it's an ordered pair. But again, to save us some work, this entire expression, 2 minus 2 sine theta, is just equal to 2, because that's r. And then cosine at 0 is equal to 1, and then minus 2 cosine at 0 is 1 times sine at 0 is 0. And then divided by negative, again, 2 minus 2 sine theta is just r, so that's minus 2 times sine at 0 is 0, and minus 2 times, we have cosine squared, so that's going to be 1 squared. Okay, so using that R trick, that kind of simplifies our work a little bit. Now we'll just simplify what we have here. So we have 2 times 1 minus 2 times 1 times 0. So that's equal to 0. Negative 2 times 0 is 0. So it looks like this is equal to positive 2 over negative 2, which is just going to be negative 1. So the slope at our point 2, 0 is negative 1. Now if we check that with what we have in our graph, we see that we have a negatively sloped line and we get a negative slope here of negative 1. So it seems like it makes sense. Next, let's look at the next point. So we did 2, 0. Let's do our point 4, 3 pi over 2. So our point R is 4, theta is 3 pi over 2. So we have dy dx is equal to, right, and we're going to do the same thing. So 2 minus 2 theta is just whatever r is, and that's 4. And then times cosine of 3 pi over 2, which is 0, and then minus 2 times cosine at 3 pi over 2, which is 0, and sine at 3 pi over 2, which is negative 1, and divided by negative, and 2 minus 2 sine theta is just r, so that's negative 4 times sine at 3 pi over 2, negative 1, and then minus 2 times, think of this as cosine squared, at 3 pi over 2 would just be 0 squared. So what does it look like we get? Well, the top, 4 times 0 is 0, minus 2 times 0 times negative 1, that's 0. So we're going to have 0 in our numerator, and 2 times 0 here over negative 4, negative 1, positive 4, but 0 in the numerator. We get 0 as our slope at the point 4, 3 pi over 2. So taking a look at what we have, does that seem like it makes sense? Well, it looks like we have a horizontal tangent line, so it seems like our derivative should be 0 there. So it looks like we got our work right. Now let's do the last one. So we have our point at r is 3, theta is, say, 7 pi over 6. So dy dx is going to be equal to, so again, starting with r over 3 times cosine of 7 pi over 6, or negative root 3 over 2, then minus 2 times cosine, again, negative root 3 over 2, times sine at 7 pi over 6, which is negative 1/2. And that's all divided by negative r, or negative 3, times sine at 7 pi over 6, or negative 1/2. And then minus 2 times cosine squared, or negative root 3 over 2, say quantity squared. Okay, now we'll just go ahead and clean this up a little bit. So let's look at our numerator. Well, we see this 2 and the 1/2 will cancel. At least 2 of these negatives will cancel. We'll still have something negative. And we'll just rewrite it on the bottom here. Okay, so that's going to give us, in the numerator, looks like we'll have negative 3 root 3 over 2 minus, what are we left with? Just root 3 over 2. Okay, now the denominator. So for the denominator, these top 2 negatives would cancel. So I give us a, say, positive 3/2. And squaring our negative root 3 over 2, we're going to have minus 2 times, say, a positive 3/4. And of course, this 2 will cancel with our 4, leaving us with a 2 on the bottom. So we can start to see, well, at least in the denominator, we have 3/2 minus 3/2, which is going to give us 0. And in the numerator, not like it matters because this is going to be undefined, but we'll simplify that. So this is going to give us, say, minus 4 root 3 over 2, which of course can be canceled, but we'll leave it as this because what we see is we have 0 in the denominator. So what does that tell us about the slope? So that says our slope is undefined, which, looking at our point, we see we have a vertical tangent line, which means we have an undefined slope. Okay. So there we are. Thank you very much.